Hello, it's Thursday, February 13th, 2025, and I had a customer ask me recently if I could develop a control panel for his layout that did not involve JMRI, but instead would use the DCC system to throw turnouts and then send an input back to the control panel so you could see the position of the turnouts because the dispatcher's panel might be in a different space. So I mocked one up today, and I thought you might be interested in seeing it. So what I have here is this board here simulates one control point on the layout. And in this case, it's lined for normal. You can see there's a green light. And then in the case of the sighting, we're going to have a red light. And I didn't have a red LED, so there's a yellow one substituted. And then there's a set of push buttons. There's a black one and a red one. And so what happens is that the control panel, the back of the dispatcher's panel, will have a mini panel associated with it. And if you've never used a mini panel, they're a pretty neat device that will allow some kind of an input, or you create a shunt or a ground between the ground wires and then one of the inputs, and that can then be programmed to do 4 different functions, whether those functions are throwing a turnout, turning on and off lights. It can even do functions like start up a locomotive and make it move forward at a specific speed step, even activate, a function or something like that. Anyway, what we're going to do with it today is that we're going to use this mini panel. So it's the input from the push buttons to the mini panel. And that mini panel is programmed to send a signal into the DCC system that says, hey, throw this accessory decoder normal or reversed. In the case of ours, it's going to throw this switch machine, this tortoise machine, normal or reverse. And currently it's set for normal. At the tortoise machine then, of course, we're using a switch-it as an input to the tortoise. And again, the switch-it is a device that can send out the 12 volts that the switchmaster or tortoise or whatever machine needs to throw one direction, and then it can reverse the polarity and throw out the other direction. And so this device has an output for 2 switch machines. So it's called a switch-it, NCE product. And so this device is only here to take the signal from the DCC and throw the turnout. Now, in addition, I also have another mini panel that in this case has an input going into the mini panel from the contacts. So the white wire is coming from their ground, and then the red and the green wire are going into separate inputs. So what will happen is that when I push the button, the mini panel says, I've seen this button selected. The mini panel says, okay, if that button is selected or that input is grounded out, I should tell it to throw accessory decoder 200 or the switch machine, which is this device, and it's been programmed to number 200, throw that normal. And if I push the red button, then the red wire says, okay, if I see the red wire or this input number 16, then I should throw accessory decoder number 200 to reverse. And that's exactly what will happen when we push the button. So the output then, the contacts come back here, and whether they're grounded with one contact or the other, this input device says, okay, on this mini panel, if I see the green output, then I should send a message to accessory decoder number 100, which is this panel here, and it should either light up the green light, or if it sees an input from the other contact, then it should reverse the polarity, and which will light up the red LED. And so altogether then, if I would choose to use my throttle, then you select accessory, in this case, number 200, and we push enter, and then it says, do you want it thrown normal reverse? Currently it's thrown normal, so I'll tell it to throw it to reverse, number 2, and of course the decoder, accessory decoder, changes the polarity and the direction of the switch machine. So the other interesting thing that's now happening, of course, is that, I will put it back to normal here for a moment. You can see on this panel that it's thrown normal, it shows green. So as I mentioned before, I'm going to now reverse it to red. and it's going to send a message to this mini panel. The mini panel is going to say, okay, if I see the red, I should tell this accessory decoder to throw reverse, and then this will change. And then once the contacts are made here, this accessory decoder says, hey, I've seen a change. Make this light change color, or tell this accessory decoder to change the color of the light. So you can see that I push the button, the switch machine throws, and eventually when the contacts are made, the light changes. I'll do it again. Here's normal. Throwing, and then back, and you'll see the flickering from the two devices indicating that they're each seeing a message. So first you'll see this one flicker down here, which tells it sees the input for the button. The switch machine will begin throwing, and then you'll see it flicker here, which will change the direction of the lights. And again, these can be separated by a very great distance. So here's reverse, and then we'll do normal again. And the cool thing about this concept is that you can also use this. You could have the input be your throttle. So again, we'll do the accessory decoder and change the direction. Machine throws, the light changes. So regardless if you use the push button or someone on your operating crew changes the position of the turnout either this way, or you can actually use a push button locally. Regardless of what happens, the switch machine ultimately sends a signal to the dispatcher's panel to show the dispatcher that something has changed. Now, obviously, if you're into JMRI, a lot of this possibility can happen through JMRI with programming and so on, which is fine. A lot of my customers are not interested in the computer, or if they are interested in having JMRI, it's maybe used for other things besides operating the layout. But if they decided to piggyback JMRI on top of this, it's still going to work essentially the same way. JMRI is going to send a signal out to the accessory decoder to change its direction, and it's going to send a signal back to the panel. So there's lots of different ways to go, but in this case, the customer wanted to flip on one switch and have the DCC do all of the operation. It doesn't take that much power to run an LED or to run the mini panels. Yes, there's a little bit of an input expense, but for the purchase of the products. But the truth of the matter is you can do a lot of layout for the cost of a laptop. So this is just one way to consider running your panels and so on. And again, if you're not a computer person, this might be the way to go. But it's pretty slick, and I'm glad I kind of mocked this up. So that's it. Enjoy your time.